All right, everybody. Man, that last video was a slog, huh? So this one's, don't worry, going to be quite a bit shorter. We're just talking about expressions versus statements and precedence and associativity. Okay, so these are some kind of like formal discussions about things that I think you've probably already picked up a bit as we've done some C programming so far, but we want to kind of step back and say, oh, what's the correct name for that concept? And then we'll use that as we go forward as well. So an expression is just some fragment of code that has a value. Code that has a value and a type. It has to have a type because every value has a type. So if it has a value, then it has a type. Now this should remind you of something. When we define variables, we said a variable has a name, a value, and a type. So an expression is like that, except it doesn't necessarily have a name. So for example, a variable like x, that's an expression. The value of it is whatever is the value of x. But so is a literal, like 51. That is a int literal that has a value, which is 51, and its type is int. So does any arithmetic expression, like 51 times 2. But then even more complicated arithmetic expressions as well, like 51 times 2 divided by 1.3. That has a certain value. I can't figure out what it is right now, but notice that it's a combination of multiple literals and they're multiplied and divided, but at the end, this whole thing in your code will have one value, whatever that is. And even if some of these were variables, it would also have just one value. And you should know also, just a little review from the last video, is that this is definitely going to be a double as well. Why? Because the last operation is a division by 1.3, so we know that's going to promote whatever this int is up to a double before it does the division. Okay, so that's an expression, any code that has a value and a type. And I'll also just mention that a lot of function calls have a value as well, such as readNum, stdin. That has a value. The value is going to be different every time you run your program, depending on what somebody typed in on the terminal, but it does have a value, and the type of it happens to be double. So those are all expressions. And a statement, on the other hand, is an instruction for the computer to do something. It's kind of like a command. And so far, what a statement is for us is mostly just something that ends with a semicolon, like a complete line, a complete statement in your C program. So if we said like int x, what's that? That's an instruction. It's telling the compiler to make room for this variable called x that has this type int. So that's a statement. And even if I said like double y equals 3 times 1.5, well, that whole thing is also a statement. It has an expression inside it, 3 times 1.5, but as a whole, it's a statement. Okay, so that's a little bit about expressions versus statements, and we'll see many more interesting kinds of statements as we start to go along. But just the main thing to remember is that an expression is any fragment of your program that has a type, and a statement is any kind of like standalone thing that you could, what makes this complete is that I could put this anywhere in my program, like inside of main, so that makes it a complete statement. Whereas if I just had like y equals by itself, that wouldn't be a complete statement because I couldn't just put that anywhere. It has to be part of some larger statement. Okay, the other thing that we want to talk about is precedence and associativity. So if you look in the notes about this, you'll see a link to this page on cppreference.com. There's other similar pages online that have precedence and associativity, but I happen to love this particular website because it's very kind of clean and simple, and it doesn't start out with like a description of what some blog poster's day was like and stuff. So this is all of the operators in C. You'll notice that there's a lot of them. We haven't used most of these. So don't worry about, whenever you're looking at some real documentation for C, you're going to see a lot of things that we haven't actually used yet ourselves. That's okay. But it's a good practice to be able to look at a documentation that has some stuff that you're not familiar with and be able to just narrow in on, here's the thing that I'm interested in. So for example, multiplication we see is right here. Sorry, that's not multiplication. Multiplication is right here on level 3. So in this chart, higher up in the chart means a higher precedence, and that means those things are going to happen first. And lower down in the chart is a lower precedence, those things are going to happen last. And the associativity has to do with when you have two things of the same precedence, which things happens first on the left or on the right. So this chart is going to be your useful resource for this. And let's look at just a couple examples and see how we can use this chart to figure out how that expression is actually evaluated. So go back to the board here. So if I have something like x plus y times z. I have two operations, plus and times. I need to look them both up on this chart. So if you look at your chart, you'll see that multiplication has precedence 3. It's in group 3 on that chart. And addition has precedence 4, which is lower down. So precedence 4. So since this is lower down, that means that this is going to be what happens first. So even if I don't write in the parentheses, this will be evaluated the same as if I had written parentheses right here. So those are exactly the same. If I wanted the addition plus x plus y to happen first, then I have to write in the parentheses into my code. Okay, let's look at a different example just to see what associativity is about. So if I said like, x or y or z. Okay, so this is the two vertical bars. That's the logical OR operator with Booleans that you know about. So now I have two things. They're both in the same precedence level. So they're both actually very low precedence. It's a precedence level of 12. So this is both precedence level of 12. But that's the only operator going on. And the question is, which one of these happens first? So then I have to look at the last column on that precedence and associativity chart is whether it's left to right or right to left. Most things are left to right. And what that means is that this one is going to happen first. So even if I hadn't written in these parentheses, the first thing that's going to happen is x logical OR with y, and then that whole result will get logical ORed with z. So that's the basic underlying rules of precedence and associativity. I've just described it really simply, but it can get complicated with very large expressions, and you'll have plenty of practice with that. And I advise you to always, don't be afraid to try something out, but the main thing is you just have to look it up on this table to see if they're at a different level of precedence, then you use the higher precedence, which means the lower number, higher up in the chart goes first. And if they're the same level, then you have to look at the associativity to see which one goes first. And then you can apply this over and over again to larger expressions.